All right, this is Mr. Martin, and these are the video notes for section 1.5, Honors Geometry. Um, if you have not read through these notes yet, then pause the video and read through them. And if you have questions about them, make sure that you make a note of what those questions are. There's a lot of information in this handout. A ton of definitions. We've got bisection, midpoint. We've got these alternate forms of midpoint, which are going to be very important for us. And you'll understand why these alternate forms are going to be more useful for us in a bit after you do some more proofs. We've got trisection, definition about trisection points. So all this is dividing segments, and then we've got dividing angles, bisection of angles, angle bisector, the ray that's actually doing the bisecting. Notice that since an angle is made up of two rays, that we use another ray to bisect the angle. So keep that in mind. The book sometimes is inconsistent about that, but we'll be consistent. And then we can trisect an angle. The rays doing the trisection or angle trisector. So a lot of information. Just pause the video if you haven't read it, read through it, and then keep this handy when we do the next problems. Okay, so moving on, what we're going to do is as many example problems as we can. I'm going to figure this out. There we go. In less than 15 minutes. Okay, so let's get right to it. And keep your notes handy. So the first three problems that we're going to do, I call these two-step proofs. Two-step proofs. Okay, and although they may not always be two steps, in this case they are, what I mean by two-step proofs is the first step are all the given, so I just consider that one step, even though it may actually be more than one step in our proof. And then directly from whatever information is given to us, we can state our conclusion. Alright, so that's what I mean by two-step proofs. Again, it may be more than two steps depending on how many pieces of given information there are. But you know, we can state our conclusion directly from the given information. Okay, so example number one, I'm going to give you some given. I'm going to give you what we want to prove. I'm going to give you a picture. We're going to do a two-column proof. So first example, we are given that ray AD bisects angle BAC, and I want to prove that angle BAD is congruent to angle DAC. And this is what my picture looks like. I've got a triangle. My triangle is ABC. And I've got another segment over here. And this is point D. Now remember, I'm talking about ray AD. And in this picture, I don't have the ray with the arrowhead showing which direction it goes. But understand that this segment AD is part of a line. It's also part of ray AD. So even though I didn't draw the ray going on forever in this direction, it still is there. Alright, so let's make our table. We've got statements. We've got reasons. Remember, the way that I show you in the example problems is the way that I'm looking for you to do it on quizzes and tests. So make sure you make your chart, make sure you label your statements and reasons, make sure that you number your statements and reasons. If you don't, you're not going to get full credit. So almost all the time, again, when we do proofs, we're going to list our given information first. So I've got ray AD, and if you want to abbreviate, you can. Bisects angle BAC. The reason for this is given. And if you go back to your sheet of notes where it talks about bisecting an angle, we see that if a ray bisects an angle, what does it do? Well, it divides it into two congruent angles. So based solely on this information here, I can go right to my conclusion. Again, I said these would be two-step proofs, so I could say angle BAD is congruent to angle DAC. Okay? And my reason, if a ray bisects an angle, then it divides, notice my abbreviations here, I'll do that a lot, the angle into two congruent angles. So I mentioned this in the last video. Notice the form that this takes. It says a ray bisects an angle here. This matches with what I have over here. Here's my key word, bisect. I see that those match. So the if part, the hypothesis, has to match with something I already have in the proof in a previous step or steps. Then, when I move over to here, divides the angle into two congruent angles. Here I've got two congruent angles, which matches with what I have over here, two congruent angles. The conclusion has to match with the statement of the same number. So the conclusion of number 2 in our conditional statement matches with the statement in number 2. Alright? Just a reminder, as always, write down questions if you have them, if you're not sure how we got something. Alright, so next example. We are given segment SR is congruent to segment RQ, and we want to prove that line PR bisects segment SQ. So again, we've got a triangle here. This is triangle S, P, Q. Then I've got another segment over here, and this is point R. So we talked a little bit about tick marks, and I didn't use them in the previous problem, but we can use them in here. Since I'm given that SR is congruent to RQ, I could put some tick marks in here so that I have a visual of exactly what's congruent. So I have two tick marks on SR, I have two tick marks on RQ. Since I have the same tick marks on each segment, we can see from the picture that they're congruent. So let's go ahead and do our proof. I've got my statements. I've got my reasons. So number 1, SR is congruent to segment RQ. My reason is that it's given. Let's try that again. Okay, and what I want to do is prove that line PR bisects SQ. Well, in order to show that something has bisected a segment, I have to show that it's divided into two congruent pieces. Do I have two congruent pieces? I do have two congruent pieces because I have SR congruent to RQ. So again, two-step proof. We'll get into some longer ones. I've got PR line bisects SQ. Okay, and now I didn't mention this in the previous problem. We'll talk about that in a second, but I need to figure out whether I want to use the definition of bisect or the converse of the definition. The definition says if a line bisects a segment, in this case it's a line bisecting the segment, that's why I chose that wording, then it divides it into two congruent segments. So that doesn't really fit here because the hypothesis has to refer back to something previous. So we want to use the converse. If a line divides a segment into two congruent segments, so that's what I have I've got my two congruent segments. That should be in a previous step, which it is in step 1, two congruent segments. Then it bisects the segment. Alright, so again, the conclusion bisects the segment, matches with the line bisecting the segment over there. Okay, so, and then just hopping back up here for a second, a ray bisects an angle. This is the definition. Remember, it's got the term in the hypothesis of the statement, so that's the definition, but again, it matched up that way. Alright, so let's move on to one more example. See if we can squeeze it in here in the time I have left. I promised it would be less than 15 minutes. Alright, so I am given that the measure of angle ABC is 90, and I am given that angle CBG is a right angle, and I want to prove that angle ABC is congruent to angle CBG. Here's my diagram. I've got A, B, C, and G. So you have to be really careful with geometry because everything has to be very explicitly stated. So it's easy to draw the conclusion that, well, they have to be congruent. This is 90, this is a right angle. Really, that's the same. But they have to be exactly the same. So we have two options here. We either need to, in our proof, show that ABC is a right angle, or we need to show that angle CBG is 90 degrees. And then once we have that they're both right angles or they're both 90 degrees, then we can say they're congruent. And then the last reason will be a little different. So I've got measure of angle ABC equals 90. I've got angle CBG is a right angle. Those are both given. Okay, I'm going to go the right angle route. So from this step, I can say that angle ABC is a right angle. And if you want to try and find your reason, go ahead and pause the video. And this would be if an angle measures 90, then it's a right angle. Right, so now you can see I have that they're both right angles, and we have a theorem that says if angles are right angles, then they are congruent. So I've got angle CBG is congruent to angle ABC. If angles are right angles, then they are congruent. There you have it. So the first and second examples, those are two-step proofs. This one is not a two-step proof, but this is going to be more typical of what we're going to end up doing for the rest of first semester and quite a bit of second semester. So again, write down any questions, come see me if you need help, and we'll see you next time.